Thank you again for joining our session today. My name is Sean Kinney. I'm the editor-in-chief here at RCR Wireless News, and we're going to have a good discussion around the business imperatives of 5G millimeter wave. I wanted to quickly go through some housekeeping notes. First, we are recording the session, and we will make that available on demand. There's an accompanying white paper on this topic that we're also going to make available. I'd encourage you to take a look at that, as it's an excellent complement for the discussion we'll have today. And please, to everybody that's attending, submit questions throughout the discussion. We reserve some time towards the end of the hour to answer those, and just submit them through the webinar portal. We'll get to as many as we can. To provide just a little bit of background, it's no secret that operators around the world are spending billions of dollars to deploy 5G while also facing relatively stagnant ARPU. So the bulk of 5G networks that we've seen come up around the globe use sub-6 GHz spectrum. We've got some limited millimeter wave 5G deployments, but investment has been slow based on some of the perceived limitations, both related to the technology and to the business case. But when the average user or potential user thinks about 5G, they're thinking of multi-gigabit per second speeds, and this is really where millimeter wave shines. So today, we're going to get into this question around the balance of using millimeter wave to deliver a truly differentiated 5G experience, and doing so in a way that's cost-effective and capable of generating new service revenues. So one more quick reminder to please submit questions throughout. And with that, it's a pleasure to introduce our speaker, Mr. Vikas Dehingra, Principal with Bell Labs Consulting.
Thanks, Sean. So thanks for the introduction. So as you can see here, we are going to look into the business imperatives of 5G millimeter wave. We look into the business attractiveness of 5G millimeter wave, the revenue potential it has for the telecom operators, and also, very importantly, the cost effectiveness of deploying 5G millimeter wave across different locations in different countries across Europe and the world. The key question that we are looking at is, can telecom operators serve 5G subscribers with better profitability and a technically superior solution by investing in 5G millimeter wave? Now, to start with, we all understand there are certain challenges for millimeter wave. It has, considering the higher frequencies, it has a limited coverage, which certainly create needs for relatively much greater number of cell sites. But that also provides us with an opportunity. Higher frequencies have larger bandwidths, which can be used to provide significantly more capacity, high throughputs in the high density locations. These high density locations can be transportation hubs, these can be stadiums, these can be shopping malls, these can be outdoor hotspots. So there are plenty of places where millimeter wave can be leveraged to provide a better quality and much more capacity. Another challenge that is being discussed in the industry for millimeter wave is obviously about its challenging propagation conditions. It has obstacles in penetrating, let's say, the hand, the body, the walls, the foliage, the rain. But again, that provides us with an opportunity where millimeter wave becomes ideal for deployment in some indoor locations and haunt zones. We can leverage millimeter wave to have outdoor to outdoor or indoor to indoor deployments. Another aspect, again going back to the high frequencies of millimeter wave, is that we can have smaller form factor antennas. It helps us in deploying millimeter wave in much more locations. We can use beamforming, which helps in extending the coverage, spectral efficiencies, but also helps in reducing the intercell interferences. And last but not the least, and especially in Europe, we see that the millimeter wave is going through a lack of spectrum. Although there are countries and the national regulatory authorities are releasing spectrum or are consulting or planning to assign spectrum, but certainly there is still a clear timeline for access to commercial spectrum is still required. Now, this has also resulted in the constrained availability of devices. We can see that the millimeter wave devices and especially the bands which are relevant in Europe, they have a relatively less ecosystem readiness than, for example, sub-6 GHz systems. The devices are certainly growing, but there is still a way to go. And that has also resulted into the network rollouts, as Sean was saying. Now, the important question that comes is, considering all these challenges, the very important question we have to see here is the attractiveness of the business viability. Now, what we do as part of this analysis, we can clearly see that millimeter wave can provide a significant revenue potential to the telecom operators. It is highly cost effective in handling capacity in these high density locations, and thereby it provides a very attractive business case. And that's what we will see. Now, if we look into the 5G deployment strategies and the monetization approaches of telecom operators across the world, the most dominant approach across the globe has been to monetize 5G by enticing the end users to increase their data consumption, entice them to higher data bundles, and thereby look for an ARPU uplift. We can clearly see that happening in few of the front runners. For example, if we see in South Korea for LG U+, 70% of their new subscribers are actually taking the plans which are 59% higher than their standard pricing plans. Similar thing we can see in US. For Verizon, 88% of their new subscribers choose unlimited plans, while out of those unlimited subscribers, 58% really choose the premium plans. So certainly, as you can see here, over the last few years, there has been a shift from metered connections to the unlimited connections. It has gone from 40% to 60% of overall subscriber base. And even in Europe, we can see that here from Vodafone, considering the migrations they have having in Spain, UK, and Italy, as more and more subscribers move to unlimited mobile contracts, they have seen an ARPU uplift of 2 to 5 euros. So clearly there is a shift by the end users to consume more data as they see a value of 5G coming in. So and now this is a very important aspect. End users have a willingness to pay if they see the value of 5G, if they can experience the differentiated quality of 5G. And that becomes very important from a telecom operator perspective to serve the end users with a good quality of 5G, if I may say, at all the places where consumers expect 5G to be there, right? And one of the important aspect of 5G realization and thereby an end user consumption is in high density locations. And if we see today, now the network performance and also the end user quality of experience, to say the least, in these high density locations remains suboptimal. So what we see from our analysis is that millimeter wave offers this required capacity in these high density locations. It offers a superior quality of experience, and thereby it enables monetizing this incremental traffic. As part of this analysis, we looked at multiple such locations. For example, in United Kingdom, we looked at train stations, we looked at outdoor hotspots, we looked at indoor malls, stadiums. And we were looking at the locations which have a certain capacity, whether it is in terms of daily passengers, whether it is in the terms of seating capacity in stadiums, or it is about the size of the shopping malls or shopping centers. So we are trying to see across these places, because of the capacity needs, can millimeter wave help to serve the capacity in a more cost-effective manner and thereby help the telecom operator? The another aspect is 5G millimeter wave enables fixed wireless access as a compelling complement to the fiber to the home services for a telecom operator. The specific areas across dense urban, suburban, or rural households where it may be costly, it may be complex, or you need to have a better time to market, the unserved or underserved homes and small offices can be very well served by fixed wireless access. And that's provide an incremental revenue streams for a telecom operator. And lastly, we were also looking at office spaces. As you can see, more than 7,200 office spaces in UK having employees greater than 70. Now, in these office spaces, 5G millimeter wave lays the foundation for connecting devices beyond smartphones. So we are talking about a market where we can connect our laptops with 5G millimeter wave connectivity. So if we consider these locations, hundreds to thousands of such locations, for example, in this case in United Kingdom, for an operator having 30% market share, we could clearly see that an operator has a potential to capture up to 4,200 petabytes per year. This is an annual average petabytes per year potential. And if we compare it again to an existing traffic or the traffic forecasted in any average year over the next 5 years for the same operator, we can see that the potential is 130% more traffic capture potential. So basically, if we talk about these, again, the high density locations and offices and serving these homes and small offices, there is a great potential out there where millimeter wave can provide superior quality of experience as it complements the sub-6 gigahertz deployments. And what does it mean? It means that for an operator, it can replicate these deployments. It can strategically select, prioritize, and then scale the deployment of millimeter wave across the hot zones, across these high density locations. So if we take the same scenario of an operator in United Kingdom across the 6 places we have listed here, we could see that for a operator, there is an incremental revenue potential of 300 million euros. That is driven by either an incremental revenue coming from fixed wireless access, an incremental revenue coming by monetizing the data capture in the high density locations, or providing enterprise connectivity for the laptops as an example in the office spaces. And if we compare this 300 million euros with an annual average mobile revenue for this operator in United Kingdom, we can see that it is up to 8% of incremental revenue. So even though you have this, independent locations which can be better served, when we actually look at the scale of these hundreds and thousands of places, for any operator across a country, they have a significant revenue potential for an operator. To understand this better, we started looking into each of those 6 locations in detail. We were trying to understand the actual real world deployments. For example, for train stations, we took an example of Gare du Nord, one of the most busiest and important stations in Paris. We analyzed the layout of this train station. We used crowdsourced data to analyze where is the data being consumed or generated by the mobile users at that train stations. We dimensioned the network at those, selecting the hot zones based upon this crowdsourced data to see really the places which are ultra dense. For example, we are looking at a particular hot zone at a train station which can cover up to 5 to 7% of the area of the station, but which carries 15 to 20% of the traffic in any busy hour. So these we consider as the candidates for millimeter wave deployment. And these millimeter wave deployments in the hot zones complement the sub-6 gigahertz or the LT deployments that an operator will have at these kind of locations. So we dimension it based upon the layout. We dimension is based upon the technical characteristics of the network and also the simultaneous users or the needs of the use cases you would have in any busy hour. What we could clearly see that the millimeter wave deployment in these hot zones at the high density location, for example, a busy train station, is highly cost effective. As you can see in the chart on the right, it provides you up to 75% cost per GB advantage. And clearly, this comes from the ample capacity that millimeter wave provides. For a sub-6 gigahertz system being deployed at those hot zones, we could see that over the period of time, for example, in this case, 5 years, as the capacity evolves, as more and more users connect to 5G, as the resolution of our devices increase, as we consume more data, the sub-6 systems will need incremental investments. But for a millimeter wave system, once you have invested for good number of years, you may not need to invest again. And that's provide the 75% cost per GB advantage that millimeter wave has. So with that cost effectiveness and the opportunity to offer superior quality of experience at these locations, where, as we discussed, the network performance and the quality of experience as of today can certainly be improved. The business case for 5G millimeter wave deployments is highly attractive. We can see a payback period of less than 4 years, a return on investment between 20 to 30% across most of the high density locations. To understand this business case, apart from the layout of the train station, understanding the hot zones where millimeter wave can be deployed, we also analyzed in detail the end user services that can be used by either the consumers or the enterprise. The enterprise in this case can be the train authorities. What we see is that the everyday applications that me and you consume or generate, for example, video on demand, the laptop connectivity, voice and video communications the way we are doing right now, or simple access of the internet. Having moderate technical requirements, they create a capacity crunch for sub-6 systems. And that's where they warrant a need for millimeter wave. Now, if we talk about emerging applications like augmented reality, if we talk about cloud gaming, which have even higher throughput requirements and lower latencies requirements, they can also be very optimally served by millimeter wave. In addition to these B2C or consumer use cases, as we just said, the train station can also have enterprise use cases. For the operational staff, as an example, it may be augmented reality being used for providing training, for doing simulation, for certain field support. It can be a proportion of cameras connected for surveillance. It can be video analytics for crowd management. Now, we can see that the number of users or the devices who are onto these enterprise applications are substantially less than the overall number of end users or consumers. But the requirements of these use cases, whether it is about latencies, whether it is about especially the uplink throughput requirements, really can put the need for better capacity. One interesting angle we could see among most of the scenarios was that the apart from the overall increase in the data usage, COVID-19 has really accelerated the demand for applications where the ratio of uplink traffic is higher. Now that may be video communications, that may be cloud connectivity, that may be tools for remote working, education, entertainment. So we see more and more applications where the ratio of uplink is relatively higher than other applications we used to have, the uplink to downlink ratio. And that's again where millimeter wave is certainly going to help us. Now, if we bring those things, as you can see on the right-hand side, this is a cumulative discounted cash flow chart where we show the investments, the recurring expenses, the revenues that a telecom operator can see over the next 4 years. So you would have investments in millimeter wave system in the first year, and then you may need investments further in the fourth year. But obviously, considering the monetization potential, as we just discussed in these high density locations, we can see that you have a payback period which is less than 3 years, and you can have a return on investment measured by internal rate of return of around 30%. So this is for one particular train station having a multiple of hot zones in that train location. The key point is that, as we had seen earlier, you can actually have a scale, a replication of such deployments over hundreds and thousands of places, and that gives the overall significant potential for uplift in the revenue or a highly cost-effective deployment. Similar to the train stations, we also analyzed other locations as we listed earlier. And this includes, for example, outdoor hotspots, which can be busy shopping streets. It can be indoor shopping malls. And what we could clearly see that in these high density locations as well, millimeter wave enables the monetization of 5G and with very attractive returns on investment. For example, you can see on the right-hand side, the business case you have for an outdoor shopping center. Here also, the interesting thing is you can see here that you invest in millimeter wave in the very first year or second year, depending upon when you start the deployment. And then over next 3-4 years, you do not need to invest again, right? But as the 5G adoption increases, you have this monetization potential, and that gives a very attractive business case. So another interesting angle we could see from the deployment of millimeter wave into these scenarios when we did the sensitivity analysis is that the size of the hot zones, the size that you're trying to serve with millimeter wave also impacts or improves the business viability. If we can select, prioritize the hot zones which are larger in size, again, considering the capacity we have in millimeter wave, it gives us the potential to capture more traffic, to serve superior quality of experience to more and more subscribers over the period of time, while our system that we have deployed gets leveraged over the number of years. That certainly improves the business viability of millimeter wave. So if the telecom operators over here accelerate the ecosystem, accelerate the deployment of millimeter wave, and accelerate the adoption of 5G millimeter wave among the end users, it improves the business viability for them as they deploy millimeter wave. So looking into another aspect of 5G millimeter wave beyond serving the existing markets like train stations or outdoor shopping malls or indoor shopping malls, we also look at the new market opportunities. And in this case, a very important aspect is millimeter wave laying the foundation for new market capture in office spaces by serving these always connected laptops cost effectively, as this offer the connectivity in a more secure and a seamless manner. Over here as well, we looked at the real world office deployment. We were looking at a particular office space. We looked at where we can really deploy millimeter wave on that in these office spaces. And one example of that is, as you can see on the chart on the left hand side, are these flexible working spaces. Now, with more and more flexible working spaces coming after this, let's say, as people start coming back, but still there is going to be this hybrid model or flexible working model for most of the companies. We can see that these flexible working spaces can be a very good candidate for millimeter wave deployments, complementing the underlying LTE or 5G midband deployments, and even the Wi-Fi deployments that will continue to exist in these offices. The point is that these flexible working spaces are relatively more dense in terms of number of employees present per square meter. They are relatively open from a propagation perspective if we compare them to, let's say, meeting rooms, to cubicles and other spaces. So if we have multiplicity of these flexible spaces or other such similar spaces in an office space, which are good candidates of millimeter wave deployments, we see a potential where millimeter wave can serve the required needs in a much better way. As we are trying to understand this, we also looked at, again, the end user applications. Here, we were looking at the applications which consume or generate data from not only smartphones, but also the laptops. And as you can see here in the chart in the middle of the slide, 96 to 98% of the data consumed or generated in an office space is actually through laptops. And this is obviously driven by increasing usage of cloud enterprise connectivity, intranet and internet connectivity, large file transfers that will happen, and growing adoption of, let's say, collaboration applications, which will further grow into using AR or VR. We are seeing more and more usage of cloud hosted applications. And we would like to have real-time connectivity to the data that we want seamlessly anywhere in much more secure manner. Which brings to the point that considering the market for 5G laptops, including millimeter wave laptops, is very nascent today. But we have a potential and we can see there is an opportunity here for telecom operators if they can work together with the OEMs, and there is a potential to accelerate the market and capture the market beyond 2 to 4% of the traffic that is generated by laptops, by smartphones. So why we see that millimeter wave is a key ingredient to serving these laptops. As you can see on the right hand side, if we again compare millimeter wave and midband to serve the same capacity needs we have listed here, you invest in millimeter wave in year one, you can continue using that deployment for at least 4 years as listed over here. But for midband, you can see from the second year onwards, we would need incremental investments. And this is driven by the increasing usage, but also, as we were talking about, increasing usage of uplink driven applications. So if we talk about the new market capture, an interesting aspect is going to be 5G millimeter wave enabled fixed wireless access. Now, what we see is that 5G millimeter wave driven fixed wireless access solutions, they can act as a compelling complement to a telecom operator for fiber to the X or fiber to the home, fiber to the curb services. The fiber to the fixed wireless access deployments can happen across different topologies, whether they are dense urban, whether they are urban, suburban, or rural. All of these different topologies have their own dynamics, whether it is driven by the household densities, driven by the environment that you have. You may have different propagation characteristics. You may have different infrastructure availability, whether it is the cell grid, the macro cell grid, whether it is the availability of your backhaul. So what we see is that fixed wireless access can be very well leverage the existing infrastructure of a macro cell grids. So you may have an existing macro cell grid for LTE, for 5G sub-6 GHz systems. The 5G millimeter wave can leverage this infrastructure wherever possible, but also considering you have smaller cell ranges because of 5G millimeter wave, you may need to densify, you may need to have more macro cells to actually provide the required quality of experience. So basically what we see is that fixed wireless access can serve these specific areas in different topologies. And we were trying to compare and see how fixed wireless access can work together, complement the services with FTTX, and what's the zones of advantage or sweet spot for each technology. How each technology in this case becomes a tool in the toolbox to serve the houses or the small offices in a much better manner. On the right-hand side, you see a zones of advantage analysis. On the x-axis, you see the sustained throughput that can be served by a fixed wireless access or an FTTH system. On the y-axis, you can see the household densities ranging from 500 households per square kilometer to around 6,000 households per square kilometer. And you can see here, these household densities are a good representation of different topologies, ranging from rural topology going to dense urban topologies. And here, to clarify, we consider sustained throughput, which means that the peak throughput that are typically marketed and served by the service providers can be much greater than these. But these are sustained throughput that a system, deployed system, can very well sustain for the simultaneous users connected to that system. And here we are actually in this chart comparing the net present value in terms of 8 years of business viability. We can clearly see that for the rural, suburban, and suburban urban households, if we are talking about a sustained throughputs up to 150 Mbps, fixed wireless access is a very good solution. It has better business viability than FTTH. But if we talk about the dense urban or urban households, where you have much higher household densities, or you have much higher sustained and peak throughput requirements, then FTTH is certainly the winner. So basically, from a telecom operator perspective, these solutions can work hand in hand to serve the maximum amount of subscribers you can do in the most business attractive manner. And also fixed wireless access can enter or serve the areas where you may have time to market advantage you need, or there may be another regulatory complications. There may be complications on laying out, for example, the backhaul requirements or the last mile requirements. Fixed wireless access can certainly help there to serve the customers as early as possible. So looking into the different locations, we were also trying to understand what are the key success factors for millimeter wave deployments. What are the key factors that will improve or make worse the business viability of millimeter wave? One of the key factors we could see was the density of the hot zones. As you can see here, we analyzed that and identified that the 5G millimeter wave has a sweet spot of between 1,000 to 3,000 subscribers per hot zone. Now, what does that mean? If you see the chart on the right-hand side, there are three zones there. On the x-axis, it is the subscribers per hot zone. And these hot zones, as we have been discussing, are the places in high density locations which have substantially higher capacity requirements than the rest of the location. And now we are talking about the number of subscribers in those hot zones. Obviously, we can clearly see that as we increase the number of subscribers per hot zone, the payback period of the millimeter wave deployments reduces, which means we are maximally utilizing the capacity of millimeter wave to serve a superior quality of experience. Now, we can also see that as we go beyond 3,000 subscribers per hot zone, although it has much better business viability, it also limits the addressable market. There may not be that many locations in any territory where you may get so many places being such dense, right? So that provides us a limited total addressable market. On the other hand, if we are talking about hot zones which have a density less than 1,000, it's also a viable business case, but the payback period tends to increase. So it has a relative attractiveness tends to reduce as we get into these kind of places, which means that the sweet spot lies in between 1,000 and 3,000 users. So what does it mean for a telecom operator? It means that you can prioritize, you can very well strategically select, start deployment where on these kind of hot zones. From a business perspective, you can decide these are the locations, these are the hot zones within the locations where I should start deploying my millimeter wave. I should be seeing a very attractive business case, and then I scale it as more and more locations are covered with millimeter wave. That being said, obviously we are utilizing the sub-6 GHz systems for providing coverage and the minimal quality of service that it requires. So to bring everything together, we see that three key recommendations for the telecom operators. The first thing, as we have been seeing for across this swarm of locations, is that we should consider deployment of 5G millimeter wave at hot zones across these locations to complement 5G sub-6 systems. It helps us in capturing new revenue. It helps us in capturing, monetizing the data that we can serve. We can see up to 8% incremental revenue potential. We can see a potential to capture up to 130% more traffic in those locations, as seen an example from the United Kingdom. So certainly we should look for the deployment of 5G millimeter wave to complement sub-6. The next thing is, beyond monetizing the data and offering a superior quality of experience in these hot zones across the locations, 5G millimeter wave lays a good foundation to capture new markets. As we were talking about connecting the laptops, setting or accelerating the market for that, which is nascent today. But more importantly, 5G millimeter wave also helps to extend the service offering to act as a complement to the fiber to the home services, and thereby increase the share of the pie, right? And lastly, and very importantly, from our analysis of the zones of advantage, the sweet spot analysis, it becomes very important for a telecom operator as they are laying out spending billions of dollars, as Sean was saying, in 5G deployments, to strategically select and then scale these millimeter wave deployments. They can look for the hot zones which are between 1,000 and 3,000 subscribers per hot zone. They can look for fixed wireless access locations which have up to 3,000 households per square kilometer. They are looking for a very respectable sustained throughputs up to 150 Mbps. So there are zones of advantage where 5G millimeter wave can become a great tool in your toolbox and help you in having more revenue, but also being much more cost effective to serve the needs of these high density locations. Yeah. So with that, I finish my this thing and we can go to the Q&A session. Thanks, Sean. Back to you.
All right. Thank you very much. Really enjoyed the presentation, and to the audience, wow, we've got some great questions here. So thank you for submitting those. We will try to get to as many as we can. So first off, Vikas, why would the relevant decision makers choose millimeter wave 5G versus Wi-Fi 6 for a traditional office environment?
Yeah, no, that's a very good question. So we could see that today Wi-Fi is serving, and especially in office spaces, those are, if we can say, carrier grade Wi-Fi systems, if I may say that. But millimeter wave, as we could see from a business attractiveness perspective, has a similar business attractiveness from a telecom operator perspective to provide a cellular connectivity which is more seamless, provides better mobility, can be more secure. So it's a from a business perspective, it may be a decision for an operator to provide a more cellular, secure and seamless connectivity while being having a business attractiveness similar to deploying Wi-Fi in those places.
All right. And then on fixed wireless access, you covered dense urban, suburban, and rural. In the suburban and rural cases, what type of conditions would an operator look for to assess the business viability of deploying?
Yeah, no, that's a very good point. So when we were looking at these suburban and rural households, as we said, the important aspect is how we can leverage the deployed infrastructure if we have. We are looking into the household densities which can be served at the right cost points, looking into certain, as we said, up to 150 Mbps of sustained services, sustained throughput. So basically, and then another point we could see was, especially in the rural areas, because you can have very high cell ranges, if you're trying to connect different users, the more bandwidth you can have. We modeled it with 400 megahertz, but if you can have higher bandwidth, for example, if you have 800 megahertz, you can very well even improve the business viability. So in these rural, suburban or urban households, for a telecom operator, fixed wireless access, it's a good solution, goes back to selecting those household neighborhoods which are underserved, unserved today, which may have a time to market needs from, let's say, an FTTX perspective. They can very well be served by fixed wireless access, and you can have a better attractive business case.
Right. I've got a few questions here on fixed wireless access and then comparison between fixed wireless access and fiber to the home. So I'm going to try to group these together, but maybe you can share with us some commentary on observed site to CPE distances for millimeter wave fixed wireless access in suburban and rural areas. What kind of coverage are we thinking about?
Yeah, that's a good question. So again, depending upon the different environments, different countries, obviously it ranges. But we were looking into certain specific examples, as I said, real world examples. So we are talking about few kilometers of cell ranges when we say the rural, and we are talking about few hundred meters of cell ranges when we are talking about dense urban, and obviously the suburban and urban lies in between. So from few hundred meters to few kilometers, and especially having outdoor CPEs, having high power CPEs can help, especially in the rural regions and suburban regions, to further extend the cell ranges. But this is typically what we are looking for, few hundred meters to few kilometers, depending upon the different topologies.
And so if we look at projections around mobile traffic consumption, we're seeing a doubling roughly every 2 years. How much would fixed wireless access sustain that growth before fiber to the home would become more necessary?
Yeah, no, that's a very good point. So we see that right now, and we certainly considered uh, 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 30 to 35% CAGR, what we typically see as far as the increase in the traffic. It can be more in certain countries, but on an average, we see that. We model that in our analysis, and you can see that the result looks like over the eight-year period, as we looked at, there are certain zones of advantage. Now, certainly, especially if we see the density in dense urban and urban, where adoption increases, then one aspect, very important aspect, can be from FWA perspective, even in rural, is how much spectrum do you have? If you have, min optimal we were looking at is 400 megahertz. If you need more capacity, you may need to have, as I said, 800 megahertz in fixed wireless access. On the other hand, we could very interestingly see that in the dense urban deployments, because of the propagation challenges, actually the fixed wireless access deployments can be coverage driven, if I may say. So because you are setting up the system, taking care of the coverage, it may be an over dimensioned system. So you have enough capacity in your system actually to supply even more households or better sustained throughputs. While for the rural and suburban, certainly the existing needs may not be that much, but as they grow, one thing can be looking into higher bandwidths, or you may need to do densification to serve more capacity.
All right, one more on this theme, then we'll shift gears. But the question from Donglin Shin: how can you compare the link reliability between fiber to the home and millimeter wave based 5G?
Now that's a good point. We did not specifically look into this aspect, but as such, yes. And that's where I think the way you deploy fixed wireless access, and also because of the technologies that are coming now in fixed wireless access, can you really use beamforming and other things in a better way? Are we looking for line of sight or near line of sight deployments? I think we can leverage as far as possible, but obviously considering the technology constraints, there will always be certain constraint with any wireless technology.
All right. And then could you please explain if the hot zones you described are selected due to millimeter wave propagation limitations or based on the operator's preference for deployment in high density locations?
Now, that's a very important point. What we say as a hot zone is a business decision. It is not entirely driven by, let's say, the propagation distance of millimeter wave, although the technology will certainly impact the decisions that we have. But for us, I think the more important question is the business decision to select the hot zones. As we were looking into the hot zones which have the right subscriber density, the hot zones which have a potential to monetize the data traffic and show the better quality of experience, I think is a more important point to actually for some of the business decision makers, rather than jumping into the technology aspects of it, which will come later anyway as we try to design the system to serve those hot zones.
All right. And in your analysis, did you consider deployment of millimeter wave using a neutral host model to help operators reduce total cost of ownership by sharing infrastructure?
Yeah, that's a good point. So we were looking at the millimeter wave deployments in the short time periods, and we were trying to analyze the business viability of that. Now, considering most of the deployments happening today for 5G are non-standalone systems, although technically it may be possible, we also acknowledge that for non-standalone systems, the RAN sharing or the neutral host systems may be a complexity. To start with the things, thereby we started with looking into a single operator deployments where an operator enters these spaces and try to serve its consumers with a better quality of experience. But in the long run, and including as the standalone system comes or as the industry evolves, we certainly believe that different forms of neutral host or RAN sharing will become prevalent. But for the short period in our analysis, we started with single operator scenarios.
Okay, and this is maybe a summary question, but I think it's an important one. So, can you take us through the additional sources of revenue that operators could see through deploying millimeter wave in terms of fixed wireless access, which we've discussed, but also premium plans and other opportunities?
Yeah. So the first is we talk about uh, serving the users with the mobile broadband as we are doing. So we are looking into 5G monetization approaches. There are multiple. As I said, the most dominant is enticing users to consume more data. It may be the another aspect of that will be bundling new services like AR, VR, like cloud gaming or other exclusive services to actually soup up, if I say, the 5G service offer. And the whole idea behind that is to entice users to go and take these 5G service plans and thereby move to the higher data bundles. In many countries, we see that 5G is through such mechanisms, whether it is higher data bundles, unlimited data bundles, bundled services, exclusive services, premium experiences, is being sold at a premium, or it is being targeted to be sold as a premium. So the point we are trying to say here is that when operators tend to monetize this aspect of 5G, a key part of that is going to be the quality of experience being uh, experienced by the end users in these high density locations. If you think about deploying sub-6 gigahertz systems, they are an essential part of it, but they may not be the most optimal solution to serve the capacity in these hot zones, and that leaves a gap, if I may say. The millimeter wave helps you filling that gap and thereby creates more customer loyalty. It increases, we have seen results coming where better 5G experiences, better network performance has improved the net promoter score for the telecom operators. So basically, the millimeter wave helps you in using these places to also provide better quality of experience and thereby show to the end users that there is value of 5G and thereby entice them to the higher data bundles and get an overall improvement or uplift in ARPU.
All right. And then how does the lack of devices with support for the 26 gigahertz band impact the business case in Europe?
Yeah. So we actually in our whole analysis we are cognizant of that aspect. When we look into the business case, we are considering a small adoption which grows over the period of time, but initial years we understand. But that being said, we also see that the ecosystem for N258 band, the 26 gigahertz band for Europe, is slowly increasing. More and more OEMs are coming. So that's one angle. But the other thing is also to see also if we see that there is a highly viable business case, we recommend operators to work closely with these more and more OEMs to accelerate the ecosystem. And as we could see in our sensitivity analysis, the more users you have, for example, in the fifth year on 5G millimeter wave, the better business viability you have. So it's like the ecosystem is growing, but then also considering the potential we have, we also need to accelerate the ecosystem.
All right. And then how can millimeter wave 5G be more cost effective than sub 6 gigahertz 5G, given limited range requires more base stations and equipment, and also that the end user devices are more expensive?
Yeah. So we were looking at this case of localized deployments. We are looking for hot zones. And if you consider hot zones, for example, in an indoor shopping mall or in a train station, we are looking about few tens of meters kind of localized places or around that. We are not looking for wide area deployments. For wide area deployment, sub-6 gigahertz systems are the optimal solution, as you said, because they have higher cell ranges. But in these hot zones at high density locations, it's a capacity needs. As far as the millimeter wave can serve the coverage aspects of it, It is the capacity that actually would make a sub-6 gigahertz system suboptimal. So sub-6 gigahertz system serves the coverage, the minimal capacity, but then you would need very less millimeter wave deployments because it has ample capacity. So it's a capacity driven design in these hot zones rather than a wide area coverage where, as we said, sub-6 gigahertz systems are more optimal.
And you've talked about this a little bit, but given the volume of questions I got here, maybe worth revisiting. But to try to paraphrase several of these, if you could just give us one more explanation of why there's a complementary relationship between millimeter wave 5G and Wi-Fi 6 as opposed to a competitive relationship.
Yeah, no, that's a good point. So let's take any scenario, an office space or any office scenario or any other scenario. Wi-Fi 6 or even earlier incarnations we had for Wi-Fi 5 and everything, they will be there. There are a number of use cases. You have your printers connected, you have other devices, you have so many things which are connected through Wi-Fi, and they will stay. So we are not saying that millimeter wave is going to rip and replace every possible system of Wi-Fi. It's a complementary relationship, as you say. We are looking at certain use cases which need higher throughputs, which needs higher capacity needs, where you need, let's say, access to your data in real time, where, for example, I'm talking about very high file transfer may be required, video communications on laptops as an example. And as I said, from our analysis, it comes that millimeter wave has a very good equivalent business attractiveness than Wi-Fi to serve these needs. So it's again goes back to the zones of advantage or the sweet spots. Both technologies exist, complement each other, driven by the business viability to serve the needs of any particular location.
You gave us a good deal of information today around why hotspots and dense urban are, likely candidates for investment in 5G millimeter wave. But I'm curious if an operator thinks a little more holistically, does an investment in millimeter wave 5G also imply further investment in the surrounding network so that the user isn't kind of jarred as they move off the millimeter wave onto that other network, whether it's a sub-6 gigahertz 5G or LTE advanced?
Yeah, no, that's a good point. So in that case, obviously, one thing is 5G millimeter wave, yeah, because of its higher bandwidth and all, provides you higher peak throughputs, which is important. But also, I think the more important point we are looking at is an end user quality of experience in a high dense environment. So if we talk about a hot zone, what millimeter wave does is it provides, if I may say, a respectable quality of experience to that every user in that high dense environment. Now, as they get out from this high dense environment, obviously you have a sub-6 system, but then the density also reduces. So the sub-6 systems again can provide you, we know you may have 100 megahertz of sub-6 systems with much lesser density of users in the constrained spaces. So depending upon, again, the density of the users, depending upon the bandwidth you can have, sub-6 underlying systems can be a very good, I would say, a handover aspect of it. So that's one case. And secondly, again, as I said, it's all about how do you manage this handovers, if it is about that, or this continuity or seamlessness of service. It's more of a how you design the network to provide this seamless service while taking care of the not only the peak throughputs, I may say, which are important, but very important is this seamless service and providing that seamless service in every kind of environment. I think that's going to be more important.
All right. Well, I want to thank the audience. Just some great questions here. Really appreciate you sending those in. I know we did not get to all of them, but we do have them logged and could do some individualized follow-up. Vikas, thank you so much for your presentation and your time during the Q&A today. And I'd remind everybody that there is a companion white paper from Bell Labs Consulting that goes into further detail around what we discussed today. That's going to be emailed out to everyone that registered for the webinar, and it'll be available for download on RCR Wireless. So thank you, everyone, for your time and attention today.
Thank you. Thank you.